Hi, friends. Welcome to another episode of Lend Me Your Engineers. I'm Madeline, your podcast co host and co explorer of all things UCF engineering. I'm here with Marissa, our marketing communications manager.
Hey everyone, happy to be here for another fantastic episode.
All right, so it's Space Week at UCF, and we are celebrating all things aerospace in the College of Engineering and Computer Science. Today, I'm chatting with Aerospace Engineering Associate Professor Tarek Elgohary, who leads cutting edge research in astrodynamics, space robotics, and space situational awareness. With a PhD from Texas A&M University, his work focuses on orbit determination, autonomous spacecraft navigation, and angles-only tracking techniques. Elgohary is passionate about mentoring the next generation of aerospace engineers and advancing technologies that support safer, smarter space exploration. Welcome to the podcast, Dr. Elgohary.
Thank you so much, Madeline, and thank you, Marissa, for having me.
Absolutely. Well, first off, why don't we chat a little bit about your research? Can you demystify space situational awareness and astrodynamics to us non-rocket scientists?
Sure. Yeah. So, without having the space in it, just general situational awareness. Essentially, the idea is if you are in an environment like you're working or trying to navigate an environment that you are in as a human being. And there are moving objects around you, and people maybe crossing the streets, and cars, and people on the sidewalk. That idea of situational awareness is that you need to be aware of what is going on around you. You need to make decisions based on this dynamic environment you are currently in. And that's not very different from space situational awareness. We have fancier words for this. So essentially, uh, 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 it, space situational awareness, including detecting new spacecraft or objects in space. So now we're adding the space to it. Essentially, making predictions of where those objects would be in the near future, and sometimes in the more longer term futures, making decisions based on these on this information, also making observations. So we in our normal life we use our eyes. In space, we have cameras, we have various sensors that give us idea of the environment around us. So that's generally the idea of space situational awareness. Not very different from our own crossing the street experiment.
That's a really good way to put it.
Thank you.
What recent breakthroughs or projects from your lab are you most excited about?
Yeah, so we've been quite lucky with several ideas that have been supported by various federal and industry organizations. And one of the projects that I am very excited about in that domain is how do we do this space situational awareness, and in some other words, it's called space domain awareness in the cislunar space. So cislunar space is the region between Earth and Moon, and there is a large interest now in creating missions and sending several missions to the moon. We have the Gateway, which is NASA's new space station in near the moon, and there is also a lot of interest from industry, from the government, from other governments in sending humans, obviously, to the moon. The Artemis project comes to mind, and also sending robotic missions. So, how to come up with ways to do domain awareness activities, to perform domain awareness activities in that region that is essentially still uncharted, still not very crowded as our current Earth orbits environment, but has many challenges as it is a lot larger than the area surrounding or the volume around Earth, and more challenging in terms of what can be done, the maneuvers that can be performed, and the kind of trajectories that can be generated in that region. So that project is one of the areas that we have funding from the Air Force Office of Scientific Research to look into, essentially how to make predictions, accurate predictions, and not just to make accurate predictions. We want to make those predictions in real time onboard spacecraft because the current state of the art rely on making predictions in based on observations coming from ground stations. So essentially telescopes on the Earth's surface. And we don't have that capability in the cislunar domain or in that region between Earth and Moon due to the large distances, due to that we cannot really cover that area with only ground-based observations. So we need to have space-based observations, and we're trying to come up with the ways to make these predictions accurately and on board the spacecraft that is actually placed in that domain and looking at that region and trying to understand what is going on and trying to make predictions based on observations. So that's one of the main projects that we have been working on for the past year or so.
Wow, that's very cool stuff.
Thank you.
So what first sparked your interest in aerospace engineering? Like, how did you know like this was the career path that you wanted to choose?
Yeah, this is a funny one because I got my bachelor's in mechanical engineering, and even during my bachelor's, I had this passion about pursuing a career in aerospace engineering. So my bachelor's was I'm originally from Egypt. So my bachelor's was from the American University in Cairo in Egypt. And it was a mechanical engineering degree. And right afterwards, I started looking at grad school in options in aerospace. So it's always been a personal goal slash passion to pursue and understand this exciting world of aerospace engineering, and to be specific, space engineering. Not, like the aero part, I'm a little bit shallow on the aero side, but I'm all into space. So that was one of the main drivers. Is that I always had this. Motivation to do that and pursue that career, and I got lucky enough that it all turned out this way.
Awesome. I think your ambition is very admirable. And
Thank you.
overall, you're welcome. What led you to UCF specifically in our aerospace program?
Yeah, UCF. When I finished my PhD, I got my PhD from Texas A&M, and in obviously astrodynamics and space situational awareness. And UCF presented a very unique experience in terms of location, in terms of its connection to space. Now we're in the Space U or the Space University Week, and that has been there since I joined. Now it's obviously getting more notice the past few years, but that culture has always been there at UCF, and that's one of the main things that drew me to UCF specifically, is to pursue that research in my area. And the focus has always been highlighted that UCF, the Space U, there's a lot of passion and interest in space research, and that essentially pushed me towards definitely pushed me towards UCF, or one of the main aspects that made me go for UCF for my academic career.
As we focus on space this week and the future of space exploration, how do you see your research contributing to future space missions or commercial space flight?
Yes. So back to this idea of performing space situational or space domain awareness operations in on spacecraft. It is if you look at exactly what we do, we look at various ideas that serve those missions or future space missions. So you can think of some of the areas that we do are essentially uh, highway cameras. One of the ideas that we are looking at, essentially, space traffic management is one area where we have these spacecraft or observers looking at important routes between, for example, the Earth and the Moon, and hopefully in the near future, Mars and even beyond, and essentially provide information for spacecraft going back and forth in these highways, quote unquote. So that's one area we're looking at, and we're looking at various aspects of this problem, and essentially how to make observations, what kind of sensors that we need, how many of those observers or spacecraft needs to be in a certain orbit. Where should we place them in this vast volume or this vast space, for example, between Earth and Moon, to make good, accurate observations, and also how to process those observations in real time to make decisions. So all of these aspects of the research, we're doing a lot of the fundamental research that can drive these applications um, in hopefully in the near future.
Amazing. And during your time here at UCF, what opportunities can you offer students who may want to get involved with you in your research?
Yeah, we do. As I mentioned, we have a relatively large group of researchers, graduates and undergraduates. We have Currently, the lab has about nine PhD students, four master's students, and about six undergraduate researchers. And we offer, our lab is always looking for, motivated students who have passion about space, have passion about research to join the lab, either on the graduate or the undergraduate level. So on the graduate level, all of the students work on the fundamental research associated with the problems that I mentioned, essentially the algorithms, how to implement this on hardware using machine learning and AI for these types of problems, testing, validation, and verification. All these problems, a lot of our graduate students are working on. Uh, on the other hand, under our undergraduate students, we have a robotics components where we test some of the algorithms that we develop, either for space domain awareness or guidance, navigation, control for space applications in a robotics in on a robotics platform that mimics or try to mimic the space environment. So we also have room for undergraduates to go and do hands-on hardware robotics experiments as well. So yeah, we're always looking for new students, always looking for motivated students to join the group, either on the graduate or the undergraduate level. You can be involved via simply sending us an email, looking up the lab, sending me or one of my students an email, and we get them integrated in the lab and the research, and they start their journey with us. One A couple of stories that has happened. I have two of my current PhD students. They are about to graduate. They essentially joined my lab as freshmen. We were both freshmen, so we were all freshmen joining the lab. So I was creating the lab, and they were freshmen undergrads. And now they are almost in their last year of PhD, going through the whole journey with me from day one until now, getting their master's, so getting their bachelor's, master's, and PhD from UCF. So that is one of the things that I'm very, very proud of. That in my lab we are able to uh, have students start in their bachelor's and go all the way to get their PhD.
That is amazing. That sounds like another success story for us.
Thank you.
I hope they're coming back as postdocs because that's gotta be hard to watch them go.
Yeah, yeah, they have been here as long as I have been, so
Wow.
it would be tough.
Yeah, that's
Yeah,
amazing. That's
yeah,
amazing.
yeah.
What advice can you offer students? Because I know aerospace engineering can be a challenging major, and students are always looking for advice and resources. So, what tips could you provide our students?
Yeah. So the good news is, so there are two sides of this coin. Obviously, as you just mentioned, aerospace can be tricky because uh, it's always has this cyclic nature. It's always connected very, very tightly to politics in general. Funding coming from Congress can create a space boom or a space bust, if you will, and that can be challenging if you're trying to navigate the job market. However, in recent years, even as we see funding coming up from the federal government, getting maybe reductions, the private sector has been booming in this space. So you have all the major and even a lot of startups, companies that are essentially recruiting students and engineers, aerospace engineers, on all levels, bachelor's, master's, and PhD, to essentially perform these tasks for various missions. And that ecosystem has been quite large and increasing. There are challenges, obviously, with space, and because it is tied to budgets and federal funding, it can be sometimes tricky to navigate. But the industry has been taking over a lot of these activities, and that's good news for a lot of our students, especially that UCF has been designated one of the top, if not the top, university that these companies actually recruit from. So I think our students will be okay in general, given our history and given the current environment. But they have to be aware that these things can change, and they can adapt in depending on their interests, their set of skills, on what they want to do. For example, some students may have this plan of, for example, joining NASA. But NASA may go through some funding cuts, but then some company like L3Harris or Northrop Grumman or Lockheed Martin are opening new divisions or new projects in space. So they have to be a little bit adaptive in that sense. But from what I see and the way things are, it seems to be a very good time to be an aerospace engineer, at least for now.
That's for sure.
Wow, and yeah, and I have to ask, with all the work that you do, who or what would you say inspires you and your work the most these days?
To be honest, I think the main thing is my I want to say my students, because so when I first started, all the ideas came from me, right? Like you're fresh out of PhD, you're joining as a fresh assistant professor, and you have all these ideas, and you're giving them to your students. Now, as we progress and the students are maturing, and I'm also maturing more and more as a professor in my career, actually, one of the main motivations or drivers of what we do now comes from the students. They come up with amazing ideas, and we chat about them. We validate them. We make sure they are not too sci-fi, if you will, and more on the more science than science fiction. And most of the time, what they come up with has been what drives our lab, versus the ideas that I can come up with. So the fact that we have a larger group of students, and they are always looking into new ideas, and we are always exploring new ideas in this space domain, or in astrodynamics in general, has been the main driver of a lot of the successes that we currently have, versus me just coming up with all these ideas. And yeah, they always keep me honest. They keep me working hard for them and with them. And that has been the main motivation for the past few years now.
Love
Before
it.
that, it
That's
was
so
getting
nice to
tenured, I
hear.
guess.
Yeah.
So before getting tenured, it was getting tenured. Now things have shifted a little bit.
I love it though. It sounds like you're an amazing mentor to our students. So I
Oh,
love
thank you.
that.
Appreciate it. Appreciate it.
Love it. Well, we like to get to know our guests a little bit better by doing a lightning round. So we will ask you quick questions, this or that questions, and just off the cuff, respond with whatever you prefer.
Okay.
Are you ready?
Yeah, sure.
Okay. Mars or the moon?
I would say moon for now.
For now.
For
Yeah.
now.
Until we
Yeah.
get to Mars.
Yes, exactly.
Exactly.
Yeah, yeah, yeah. No, because there is, as I said earlier, there's a lot of interest in the moon at this point, and it will be our gateway to Mars and beyond. So I like to focus on the moon and resolving a lot of the problems that are currently gonna pop up in that environment, and hopefully this will make our journey to Mars and beyond a lot easier.
Makes sense.
Yeah, definitely. And then next one, robots or rockets?
I'm gonna go with robots because part of the lab name is robotics, so I'm gonna stick with robots. We don't do rockets in my lab. We love rockets, obviously, but we're not a rocket lab. We're not a propulsion lab. We're more on the robotics side of things. So I'll stick with robots for now.
Got it.
But space
Teaching
robots, so robots in space.
space robots, it's even better.
Yeah, yeah.
Teaching or research?
I'll lean more towards research for sure. I have nothing against teaching, but research I think is more gratifying in my opinion.
Interesting take. NASA or SpaceX?
NASA, more leaning towards NASA.
Star Wars or Star Trek?
Ah, that's a tough one. I'm gonna go with Star Wars.
Yeah.
That's the correct answer for
Yeah,
sure.
yeah. Well, for
I was like,
fifty
you better say
percent of
Star
the
Wars.
yeah, for 50% of the population, right? So
Yeah.
so it's always like a tough one, but
It's
I'm
tough,
more of
yeah.
a Star Wars fan. Yeah,
Okay, and then next, kind of a polarizing one, but
yeah.
coffee or tea?
It's coffee for me. It's has kept me going since the last couple of years of grad school. So before then, I didn't drink any coffee or tea. But towards the last couple of years, there was a crunch, and I haven't stopped since then. So coffee is what kept things going so far.
It's always either or. There's never like
Yeah,
in the middle. Yeah.
yeah, yeah.
Early bird or night owl?
I prefer early, and yeah, I always like to. I'm more productive early in the morning versus at the end of the day.
Nice. I wish I was like that.
No, me too. I was thinking the same thing.
Yeah.
Conference talk or journal paper?
This one is tricky because uh, uh, obviously for our PhD students, journal papers are very, very important because that's how they get their dissertations and that's how they graduate. But definitely conferences are also very important because this is how you disseminate and explain and present that work. So I'm gonna say 50-50 here because both of them serve a very, very important purpose for advancing the research. I don't think one or the other is gonna be sufficient for this one because they have to all work hand in hand.
That's fair. That's fair.
Yeah.
Cairo skyline or Florida sunset?
That's a tough one. um, yeah, I'll go with I'll go with Florida sunset. I love Cairo. I love the skyline, but it's more the Florida sunset is definitely more relaxing, more I guess very very nice to watch and be there when it happens. So definitely Florida sunset.
The colors
Got
are
it.
like nowhere else here.
Exactly,
Yeah.
exactly. And Cairo is a big city. You don't really see the sky. And, yeah, it's a lot of buildings and so yeah, it's definitely a beautiful skyline. But the sunset is more of my preference.
Got it.
Fantastic. Well, that's a great way to end it, and that's all
Thank
for
you.
this episode. Thank you so much to Dr. Elgohary for chatting with us today. For more episodes of our podcast, visit Spotify or Apple Podcasts and hit subscribe. You can also follow us on social media at UCF CECS or at UCF MAE. Until next time.